Hey guys, so today we're going to move on to Chapter 8, within Chapter 8 to Section 4, and we're going to start to discuss adding and subtracting radical expressions. So our objective is for today, just to simplify radical expressions involving just addition and subtraction. Alright, so only radical expressions with the same index and the same radicand may be combined. Alright, so again, if you remember, when we talked about this is the index, and this is the radicand. Okay, so you look at the top one there, you look up top, 5 square root of 3 plus 2 square root of 2, different radicands. Okay, on the next one, 3 square root of 3, 2 cubed root of 3, again, we do not have the same index, so we can't combine those terms. So those will be just marked as they're already simplified. Okay, so we've got 3 square root of 5 plus 7 square root of 5. We have identical radicands. What we want to do is we want to treat those sort of like this, as x. So if I had 3x plus 7x, you would just simply look at that and say, hey, that's really easy. That's 10x. You're going to treat those radicands just like a variable. So in this case, 3x, or excuse me, 3 to the square, 3 square root of 5 plus 7 square root of 5 is going to be 3 plus 7 square root of 5, or just 10 square root of 5. Okay, it's not that difficult, but now we start to throw a little bit of extra stuff in there. So we've got 2 square root of 11 minus square root of 11 plus 3 square root of 44. Well, right here, this ought to be a little bit of a clue that we're going to be having to factor out a perfect square. So the perfect square in this case would be 4. So we'd end up with 2 square root of 11 minus square root of 11 plus 3 square root of 4 times the square root of 11. So 2 square root of 11 minus 1 square root of 11 plus 3 times 2 times the square root of 11. So we can move that down. And 2 minus 1 plus 6 times the square root of 11. So it's 7 times the square root of 11. Okay, if we have a variable under the radical sign, we treat that just like we've always treated them. All right, if we can't factor it out, we leave it in there. So we have 5 times the square root of 12y plus 6 times the square root of 75y. Well, you're going to have to look at this values right here, and you're going to know that 4 times 3 is 12, so 4 is your perfect square. And this is another one with 25 times 3 inside, right? So you need to recognize that some perfect squares are going to go in. So, and we always want to try to end up with the same values under the radical sign. So this would be 5 times the square root of 4 times the square root of 3y plus 6 times the square root of 25 times the square root of 3y. And we simplify further, 5 times 2 times 3 times the square root of 3y plus 6 times 5 times the square root of 3y. We end up with 10 times the square root of 3y plus 30 times the square root of 3y. 10 plus 30. So this, our final answer is 40 times the square root of 3y. Now this last problem here, we can just look at those radicands. You cannot take, while 10 can be factored as 2 times 5, you can't do anything with it. You have to have a perfect square that you're going to factor out of this. So Can't be simplified any further. All right, so caution. Do not confuse the product rule with combining like terms. The root of a sum does not equal the sum of the roots. Let me say it again. The root of a sum does not equal the sum of the roots. For example, so the square root of 9 plus 16 does not equal the square root of 9 plus the square root of 16. Because 9 plus 16 is 25, the square root of 25 is 5. But the square root of 9 plus the square root of 16 is 3 plus 4 equals 7. So this is the correct way of doing this. Okay, you don't split that up. Okay, you treat that as one entity. This right here, what's under the radical sign.